Okay, so we have e to the power of x over e to the power of 2x plus 3. Okay, for this one, let's convert this in terms of u. Okay, and I know that I need to convert that into u because we have e to the power of 2x and x. Right? That's a if this were to be u, this would be u squared. So it's a quadratic relationship there. So let's see what happens if I let e to the power of x equal to u. Okay, of course e to the power of x dx would be then du. So I can actually replace that with du, and the bottom can be replaced with u squared plus 3. Okay, so now we're dealing with the derivative of arctangent. Okay, so let's divide the top and bottom by 3, and we get, if we divide the top by 3, you get 1 over 3 on top. The bottom I get u squared over 3 plus 1, right? Which can be rewritten as u over root 3 squared plus 1. Okay, so that's going to be a third, right, arc tangent of u over root 3. Okay, and normally if I differentiate that, I gotta times it by 1 over root 3, so I gotta times this by the reciprocal of that, root 3. Okay, so in here I gotta plug in my numbers. 0, right? Actually, when x is equal to 0, you see that u is going to be 1. And of course, when x is going towards infinity, u is also going towards infinity. Okay, so this can be rewritten as root 3 over 3, limit t approaches to infinity. Okay, we have arctan u over root 3. Okay, and we have a t and 1 here. Okay, so then we get arc tan of t over root 3 minus arc tan of 1 over root 3. So arc tan of 1 over root 3, you know that pi over 6, tangent of pi over 6 will give you 1 over root 3. So this is going to be pi over 6, like that. Okay, like that. So as t approaches to infinity, right, t over root 3 is approaching infinity, and you know that arctan is going to approach pi over 2. Okay, because tangent graph approaches infinity at pi over 2. Alright, so root 3 over 3, this is going to be 3 pi minus pi all over 6. Root 3 over 3, 2 pi over 6. Divide, and you get root 3 pi over 9. Okay, over 9.